pleasure to be here with all of you this morning and speak to such an educated group about watersheds. It's an opportunity for us to share some of the work that we're doing, so we really appreciate you having us on board today. So maybe first things first, for those of you who don't know the Stroud Center, Stroud Water Research Center's mission is to advance knowledge and stewardship of freshwater systems through global research, education, and watershed restoration. And if you don't know, we're located in southern Chester County. We've been working down here for 54 years now. And if you don't know, we do freshwater research. We have an environmental education group that provides programs to, in non-COVID times, over 10,000 people per year, and a watershed restoration group. And those three systems and units work collectively at the Stroud Center. So you might be wondering what we have to do with technology. And if you're new to the Stroud Center, I'll introduce you to our high-level umbrella of technology tools called Wiki Watershed. So there are a number of different digital and tangible tools underneath the Wiki Watershed umbrella. And today we're going to talk about two of those in particular, EnviroDIY and Monitor My Watershed. And these efforts are a huge team effort with folks not only here within the Stroud Center, but also external partners. And so this is definitely a team effort over about a 10-year period to pull together the tools that we're going to share with you today. That's been funded through a wide variety of different programs to get us to where we are. All right, so cutting to the chase, we measure water, and I'm saying we at the Stroud Center, you out there as watershed specialists, we measure water in two ways. We take water samples and we analyze those for chemistry, and we also measure in situ with electronic gadgets. And so today we're focused on the electronic gadget end of things. And with those electronic gadgets, we can measure in two ways. We can either put those instruments into the water ourselves with our hands, make a measurement, go to the next site or go home, or we can put equipment out in the field and leave it out there to make continuous measurements. So we either talk about discrete measurements or continuous measurements. And for the most part today, what Dave Bressler is going to introduce you to are continuous measurements. But keep in mind that all of the information you're going to get today about EnviroDIY can translate into building your own devices for handheld measurements as well. But most of the discussion here is going to focus on continuous monitoring in situ. So if you're new to the word DIY, do it yourself, it's an alternative to buying equipment off the shelf. So for example, on the right-hand side of the screen, you could go to YSI, a number of different vendors. I'm just showing one from YSI here, and you could order a system that comes in a box and it's ready to go with an instruction manual. You can get it connected to the web. It's solar powered. You can measure in situ, more or less off the shelf. The alternative that we're going to talk to you about today is doing it yourself. So this consists of assembling a number of different parts and putting those parts together into a box, programming it yourself, and connecting it to a sensor yourself. So from the Stroud Center's perspective, when we talk about do it yourself, we're mainly focused on putting the brains together yourself. For the most part here at the Stroud Center, we do buy off-the-shelf sensors, and there's a picture of one down in the lower left corner of the slide. Dave Bressler is going to show you a lot of detail on that today. So again, when we talk about do it yourself in EnviroDIY, we're mainly thinking about putting together the electronic brains, the solar panel, the microcontroller, and all of that yourself, but buying an off-the-shelf sensor. So that's our perspective, is that we save money on the brains, but we don't skimp on the quality of the sensor itself. So one thing that you should consider, and you're going to get a good taste for how to make this decision today, as Dave Bresler shares with you a lot of the details of how to do this. But you need to carefully consider whether this approach is right for you. And I think there's 5 different ways that you could think about this decision, about whether you want to go down this do-it-yourself road. The first and the most often talked about one is cost. Do-it-yourself is cheaper than buying an off-the-shelf system. And I'll give you a little bit more detail about that in the next slide. From the standpoint of real-time remote data relay from sensors in the field, you can get that from both the do-it-yourself system that Dave's going to introduce you to today, as well as off-the-shelf systems. The difference is that for the most part, the do-it-yourself real-time data visualization and data sharing from the DIY perspective is public. So you're sharing the data instantly and in real time with the public all the time. You don't have a way to keep the data private to you. Whereas off-the-shelf systems, commercial systems, will allow you to keep the information to yourself in private. And generally, it's going to be a little bit harder to share that with the public at large. So that's a big difference in these two systems. And generally speaking, we look at the publicly available side of the data from EnviroDIY, the things that we're going to talk to you about today, as a benefit. And we look from our standpoint, from the kind of work that we do, we look to that private shielded data as not what we want. So that's why the letters are in green here. We think that public data and free access are good from our perspective. So let's work our way down the list. The 2 things that are very different about do-it-yourself versus commercial systems is that it takes some skills and it takes some time to do it yourself. So off the shelf, you can order it, it'll arrive on your doorstep, you can plug some things in and you'll be off and running more or less. To do it yourself, you're going to have to educate yourself, you're going to have to train your people and yourself, you're going to have to find specialists within your specialist groups who have the skill set, who have the time, who have the motivation to learn how to do this. And again, you're going to get a good sense for this from all the details that Dave Bresler is going to share with you in just a moment. And finally, the important thing to remember, one of the big differences with do-it-yourself versus an off-the-shelf commercial system is that when you do it yourself, you're generating something that has really flexible applications because you're programming it yourself. You're really designing this thing that you're going to measure water with from the bottom up. And what that means is that in the long run, what you build is far more flexible in what you can make it do, what sensors you can attach to it, than if you bought a commercial off-the-shelf system. So keep those things in mind. Let's return to this idea of cost. From the DIY perspective, it's very popular to turn to DIY approaches because they're cheaper. That's generally true. How much cheaper is, it depends. I'm showing you a comparison here. On the left is the device, the EnviroDIY Monitoring Station, that over the next 45 minutes, Dave Bresler is going to really give you the details of what this is all about, how to build it. You can connect that monitoring station to a temperature, conductivity, and depth sensor for about $1,000. A few more tens of dollars are required to put it on a post, to buy some parts to put it in the field. The comparison off-the-shelf system, to the best of my knowledge, commercial system, the cheapest commercial system is about $2,100. So I think we're talking about a cost savings of about 50% when you do it yourself. And from my experience, I would say that a 50% savings for the DIY approach is generally probably going to be true no matter what you're doing, no matter what parameters you're measuring or how you're going to do that. So there is a real cost savings. And again, you need to carefully consider what's your budget, what's your time, and where do you want to spend your money and time to do this type of thing. So Dave Bresler is going to introduce you to 2 of our different Wiki Watershed tools today. The first is EnviroDIY. EnviroDIY is a website. It's a community of people that we're growing. We have 700 members and growing around the world. And these are people that are engaged in training, learning, sharing how to do DIY water monitoring or environmental monitoring. Generally speaking, all of these approaches are open source, and we're using hardware and software, which is open source, meaning that you can use it, modify it, adjust it, sell it on your own without any restrictions. The other tool that we're going to talk about today is Monitor My Watershed. So this is a web app that allows you to visualize and share your water quality monitoring data openly, publicly, and for free. So let's talk a little bit more about EnviroDIY. Again, it's a website. Check it out right now if you want, EnviroDIY.org, and you'll find this header at the top here. So there's 3 ways that we engage the community. You can participate in workshops as a member of EnviroDIY through training workshops. You can post things to the website in blog form. These are oftentimes very detailed blogs that explain how to do things. And you can ask questions and get questions answered from not only the Stroud Center, but other of the 700 members on this website through the forum site. So we've trained we think around 500 people through our workshops. We've got 2,000 plus different Q&A questions and answers on the forums. And I think about 60 different blog posts that give you details on all this. But I think it's a little bit of a misnomer that we don't acknowledge enough. This isn't actually really doing it yourself. It's really doing it together. And that's what the website in this community is all about. It's about sharing, it's about supporting, and we provide a ton of materials on this website to allow people to learn more through manuals and videos and training and workshops. So Dave Bresler is going to explain a lot about this device here. This is the Mayfly Data Logger that our engineer Shannon Hicks designed here at the Stroud Center. And we use it almost exclusively because it standardizes not only our instruction, but also our implementation of projects in the field. So you can buy this, and Dave Bresler will give you more details about how to get hooked up with this. And it's also worth mentioning that, as Dave's going to explain to you, we program this little brain using an open source program called Arduino. So all of this is open source. You can make this yourself if you want to. The instructions are out there. If you're really techie, you don't have to rely on us to build it. You can make it yourself if you want to. Let's connect this EnviroDIY monitoring station with Monitor My Watershed. Again, what Dave Bresler is going to explain to you is this device. You can make it, you can put it on the bank of a river, it's going to measure things, and it can send its data in real time to this website, Monitor My Watershed. So you can go there, monitormywatershed.org. And when you're there, you'll reach this landing page for the data sharing portal. If you select browse sites there right next to the Monitor My Watershed logo, you'll end up at a map of the world with all of these different pins from people all over the world who are sharing data from a device to the web. Most of these are water monitoring data, but they don't have to be. They can be air monitoring data, soil monitoring data, and weather data. If you click on a pin, you'll get more information and details about what's being measured there: water depth or temperature, conductivity, turbidity. And you can see the most recent data from that sensor in real time as it's coming into the Monitor My Watershed website. You can dig a little bit deeper, and you can actually plot up in a customizable way. You can plot different parameters together, different sites. This is an example down in New Zealand. I wanted to just emphasize that this is a global effort. So there are people all around the world doing this. And Monitor My Watershed allows you some real great tools for making a custom plot of the parameters you want, the time period you want, different sites. And this is really helpful for not only understanding yourself, but explaining that data and what it means to other people for your own purposes. So that's all I have in my slides, and that's just to tee up Dave Bresler's efforts here to dig in deeper. So with that, I'll look forward to any questions. I'll be hanging on to answer questions in the chat. If you have anything specifically you want to ask about what I just presented, And I'll turn it over to David Breslin.
Thanks, Scott. Just going to share my screen. And we're off. Okay. So I'm going to go into details here, talking about building a station. Our goal, simply to, hopefully when we're done here today, you'll understand what it takes to build one of these EnviroDIY monitoring stations. I'm going to talk about programming the Mayfly Data Logger, building the station, taking it out, installing it, and then Cheryl's going to talk about her personal experience of doing this. So here's the Mayfly. This is an older version. The version Scott showed you is a brand new one that Shannon has just built. So as Scott mentioned, this is the brains. Essentially, it's a programming microprocessor. And EnviroDIY is kind of centered around this Mayfly Data Logger. Scott didn't mention the standard station. So we kind of have a standard station that the manual is based around. The manual on EnviroDIY.org describes building this particular station. Pelican box, solar panel, Mayfly board inside, battery hooked to the solar panel. And then this is what we call the sensor bundle, which is the sensors in the stream with the removable pins so that you can keep depth standard and you can remove these sensors relatively easy from the stream. Here's kind of a broader view of it. You can see the logger on the bank, wires running down the bank to the sensors in the water. Here's a little bit more of close-up. You can see solar panel running down here. It comes in the bottom, attaches in here, and then is charged by the battery. Here you can see a close-up, sensors attaching here to the Mayfly, so on. Here's the Mayfly board. I'm certainly not going to go through all of this stuff, but just pointing out a few features. Here's the on-off switch. SD card, there's a vertical SD card that will go in here. Your solar panel and batteries are attaching here. Your sensors are going to attach in this region. A little more close up here of the cell board. So we attach a cell board to the Mayfly that then allows you to transmit the data to monitor My Watershed data portal. The cell plans for this generally cost $5 to $8 per month. Here is a little more close up of the sensor bundle. You can see these sensors attached with a hose clamp. We're talking mostly today about the CTD sensor. Workshops and such that we've been doing are focused on the CTD sensor. The manual does describe using the turbidity sensor, but we're going to focus mostly on the CTD sensor today. You can see here on the back, just tightening. You can loosen and adjust these if need be, the hose clamp. And then you can see here again, this pin that allows you to put this PVC on which the sensors are attached over top this rebar that is driven into the stream bed. You can remove this bundle to clean the sensors and to inspect them. And then a close-up here of the actual sensors. This is the CTD sensor from the meter group. It's called the Hydros 21. They are coming out with a new version sometime soon, which we'll be switching over to. Just a few key features here. The ceramic disc here is the pressure transducer. That is sensitive, so you have to be careful of that when you're cleaning the sensors. These screw heads are where the conductivity is measured. You have to clean those. You use the long bristles of a brush to get in there and clean those to prevent fouling. This is the turbidity sensor from Campbell, so OBS 3+. This also has actually been phased out, and Shannon is testing some new turbidity sensors, hopefully which will be less prone to fouling. This does have fouling issues because it shoots 12 to 18 inches out into the water column, and this eyeball can get fouled by sticks, biofouling, etc. And then I mentioned the SD card. We have this little attachment here that allows you to more easily access the SD card. That is where the most secure data are going to be. If cell coverage goes out, you're still going to have data logging to the SD card. And then Scott mentioned data are transmitting to monitor my watershed. Every 5 minutes, we have these boards generally programmed to collect data points. So you can see here, there's a timestamp on every data point. And then you can see the different parameters here being collected: conductivity, depth, temperature, turbidity. And then you've got the battery of the power level of the Mayfly. Data sent in real time to monitor my watershed. Again, sending to this data portal where you can see sites. You can have quick 72-hour feeds. This is your real-time feed right here. And then you can go into the time series analyst to overlay variables and to look at all of your historical data. You can also overlay sites. So you can compare sites between one another. Okay, so this is Rachel Johnson, who is one of the main EnviroDIY technicians. She and Shannon really have I'm more generalist when it comes to this stuff. Shannon and Rachel are the real specialists. So a lot of these slides I'm using here today are actually generated by Rachel. So I'm gonna just give you an overview of the entire process of building these stations, and then I'll go into the details of each of these components. So preparing for building, registering on EnviroDIY, registering on Monitor My Watershed, working with your cell capacity, so confirming that you do have cell coverage, for instance, 4G cell coverage, and then just gathering your equipment. Then you're going to prepare the Mayfly Data Logger. You're going to get the Arduino software onto your computer, and you're going to connect it up, the Mayfly, to your computer. And then you're going to program. You're going to install the libraries, kind of all of the support information to run the programs, or sketches, as they're called in the Arduino environment. And then you're going to go ahead and assemble your station. I'm going to talk today mostly from the perspective of using the EnviroDIY monitoring station kit. The manual actually goes through a building from scratch, but an easier way to do it is with this monitoring station kit, which assembles a lot of the ingredients for you. And then you're going to just go out and install the station. And there's a lot of kind of subtleties to that. It seems simple, but there's a lot of subtle details that you really have to pay attention to. So here we go. So there's just a kind of a picture diagram of what we're going to be doing. So you prepare with your accounts, getting Monitor My Watershed, Arduino, and hologram set up. Then you're going to program your Mayfly to talk to the sensor. And you're going to program the Mayfly to talk to Monitor My Watershed. Then using the EnviroDIY monitoring station kit, you're going to assemble the station for the most part to get to this point. And then you're going to use that kind of mostly assembled station along with these types of supplies and equipment to install the station out in the field. Okay. So going into the programming part. First thing, installing Arduino on your computer. You go to the Arduino site, and then if you're on Windows, you can go that route. If you have a Mac, you can go that route. You're simply getting this software onto your computer so that you can talk to the Mayfly and program the Mayfly. Okay. Then you're going to tell your Mayfly Data Logger, you're gonna add this particular logger via this link to the Arduino communication pathway, so that your computer can actually interact with the Mayfly board. So I'm just going through a few of these steps just to give you a flavor of what is involved. But this is the kind of stuff that is just, you would be walked through in a workshop, for instance. So then you're going to attach your Mayfly to the computer. You're going to connect it up with the correct port, just to further the ability to communicate. Each time you connect a different device in, it comes up with a different port, so you just choose the right port. And then you're going to load in all of your, excuse me, all of your support documents, your support libraries and sketches via this link. This is all via GitHub, which is kind of the repository of all of this these different libraries and sketches, programs for programming your Mayfly to talk to not only this CTD sensor that we're talking about today, but talking with other sensors. Then another step here in getting your Mayfly set up, you're going to set the internal clock. There's specific directions for getting that perfectly set. It's a simple step, yet it's very important because you want your Mayfly to be right on with regard to real time so that whenever it stamps your data coming in, it does it accurately. So then you're stepping back briefly from the Mayfly and Arduino, and you're going to register on Monitor My Watershed. You register a site, add in your coordinates, your specific location for the site. You're going to add the specific sensors that you're going to be working with. So in this case, you'd be adding the meter Hydros 21 sensor. And then once you do that, there will be these UUIDs generated, these universally unique identifiers, which you will then use. You'll incorporate these into the code for the Mayfly so that your Mayfly can directly communicate with Monitor My Watershed. So there's that linkage between the code on your Mayfly and Monitor My Watershed so they can talk to each other. And then you're going to bring in your actual you're going to upload your actual sketch to the Mayfly. That is programming your Mayfly with all of the proper functionality to communicate with the sensor and with Monitor My Watershed. You're going to adjust that sketch with, you're going to add in your specific logger ID or your site ID. Just a sort of an example here of how you would adjust this, and you would add in your specific logger and site ID. And then you take the UUIDs from Monitor My Watershed and paste them directly into here. They would be formatted exactly right. And that's really the idea of this DIY process, even with programming, where you're copying and pasting things, code, as well as these UUIDs and such, instead of just typing it all out yourself and programming yourself. You're really just copying and pasting code. Okay, so that's the programming dynamic. And I'm getting some, so I encourage everyone to mute. Getting some feedback here. So on to building these sensors, the station. So you're going to take your monitoring kit, you're going to assemble it to this point, and then you're going to install. But I'm going to go through this process of getting to this point right now. Okay, so these are your this is your general supply list. You've got your monitoring station kit, which is here. You've got all your different parts, your logger box, your solar panel, your solar mounting materials, your Mayfly, your little Mayfly box. You've got cell parts here. This is sold on the EnviroDIY site. The only thing you have to buy in addition to this is a lithium battery. That has to do with shipping and such with regard to lithium products. You're going to buy, as Scott mentioned, we get sensors from the manufacturers. So you would buy that sensor from Meter Group, the CTD sensor from Meter Group. And then you have this list of installation equipment and supplies. And those lists are provided in the actual EnviroDIY manual, which you can get through, again, through the EnviroDIY site. So a few steps in assembling the monitoring kit. Pretty easy peasy, really. You're just doing things like attaching your vertical SD card to the Mayfly board here. You're hooking in your battery. You're adding your cell board to the Mayfly. Excuse me. Sorry. You're hooking your solar panel wire in So you're kind of prepping things. You're going to assemble your logger box. So you've got these little parts. You're kind of just setting the box up for installation out in the field, attaching this bar to the back, getting things situated, getting these gaskets plugged in there nice and tight. These are waterproof, so you have to be careful getting these in just right. And then assembling the solar panel. So you're taking the solar panel, attaching it to this mounting plate, using a few little parts to get that situated. And then you've got your stuff ready. The sensor bundle can be kind of done iteratively. You can do some of this before you go out in the field. You can do some of it in the field. Some of this is kind of dependent on how you personally like to work. But in this case, you're taking some additional parts and getting this sensor bundle set up. I'll go into a few other details of that with the installation process. And then you're going to do a few other little things to get this whole setup situated. You'll kind of take the Mayfly and put it into this little box and put it in here in this foam, get everything snug and nice and secure in there. And then you're ready to take that whole setup along with your installation equipment and go out and do it. So, but before you do that, you need to really think about where you're going to place it and consider these types of things. So, you know, as we know, storms can be very damaging. And there's obviously parts of the stream that are going to be more dangerous than others for a station like this in terms of vulnerability to damage. Certainly there is a freezing damage risk in the wintertime. Low water is certainly something to consider, especially in streams that come up and down a lot through the seasons and that are exposed to drought conditions. Vandalism is certainly something to consider from people and animals. And then you definitely want to be cognizant of just who is going to be maintaining the station and then what they are going to need in terms of being able to access the station safely and without too much hassle, really. So some site selection considerations. Storm conditions. As we know, storms can get super bad. This is Angelica Creek. This tree floated downstream. This is not a big stream, and yet the water was high enough to bring this giant thing down this stream. So you can imagine if that hit a sensor, it would likely destroy the sensor. So if at all possible, you want to kind of shield these sensors with natural obstructions. So what we have here, this is on Pennypack Creek. The water's flowing this way, so right to left. You can see this is Rachel here after having installed this station, and you can see she kind of put it downstream of this tree, and there's a reason for that. This is looking from the other way. This is that same tree. There's the top of the station, and this station is actually held up. This Pennypack Creek is outside of Philadelphia, and it comes up way high and gets super flooded and super powerful. And yet this station has been protected simply by this tree and because of careful consideration in positioning it behind this. If it wasn't positioned behind this tree, it probably wouldn't be surviving. So in this case, you can see there was buildup, water flowing again, right to left. And this station was in front of this tree, and you can see it was totally taken out by debris. And yet, this station remained functional. So even though it was destroyed, essentially, or taken out, it still kept transmitting data. So it's an important consideration that George is going to get into tomorrow, that even when your station continues transmitting, you still need to check on it, because sometimes these things are so resilient. Shannon has built such a resilient machine that it'll be in this condition and it'll still be transmitting. Now that's not sustainable, obviously, so it's going to be important to check things out. Sediment burial is a is very popular among these streams, happens often. This is a stream, there is a sensor buried under here somewhere. One storm did this, it brought all this sand through, covered the sensors, and then this was at the Independence School in Delaware. And this is Rachel and some students digging the sensor out, which is common practice, really. You have to be prepared for that. The sensor survived. It was reading inaccurately. It was having wacky readings when buried under the sand, but they unburied it and it did survive. So they're pretty resilient, but you need to be prepared for breakage as well, because it does happen. So you do your best in putting these stations out, but you can't really predict what's going to happen. And so you really have to be prepared to just allow these mistakes to be as they are and learn from them and adjust accordingly with these stations. So winter, ice can be a damaging influence, not inherently. In this case, if the ice were to freeze all the way down to the sensors, that pressure transducer I mentioned can be damaged if ice freezes directly around it. If ice is above the sensors, just around the wires, it'll be perfectly fine. So most stations are left out through the winter, but in deploying them, you really need to think about, is this going to freeze? How deep is it going to freeze? And are my sensors going to be vulnerable to being having that ice freeze directly around them? Drought conditions, here's a site on the Schuylkill River, which has pretty dramatic changes in water levels through the seasons. Here we put these in the springtime and didn't properly consider low flow. And so when it came to drought conditions, these sensors were exposed. Again, this was something we just sort of had to adjust to and reposition these sensors. Vandalism. So this is Kim Hatchadorian, Nature Conservancy in Delaware. She works with the First State National Historic Park. This is a popular hiking trail here. Unfortunately, she had 2 stations vandalized, where this station was knocked over and stolen. This station, you can see all the logger box and everything was stolen. So it does happen. We encourage signage to help prevent that. It's a nice sign from Trout Unlimited. And then we do have animal vandalism. This chewing of wires happens a lot. In some cases, it's necessary to put a metal conduit around the wire to protect it from animals, beavers, muskrats, squirrels, etc. Molly, how am I doing on time?
Hi, Dave. I'm going to give you till 9:35, so it's 9:22. You have a little bit left.
All right. Okay. Okay. So, and then the last thing for thinking about how to, what to consider in deploying these stations, access, if you're someone that is really kind of agile and such, you may not think too much about access, but when you're thinking about different people maintaining the station, you really need to be careful about that, because the more you're out in the field, there's risk. There certainly is risk in being out in the field doing this type of work. So you need to be cognizant of doing proper risk assessment with regard to access. So here's a station where they tied a rope to this tree in order to be able to get down into the stream to access the sensors with less risk of falling. Also making the sensors as accessible to roads or trails as possible. This is a main trail here, and then you can see they're pointing to a side trail that leads to the station. Here's a station on, excuse me, on Pickering Creek, where there's a footbridge, and it's near the YMCA, so they wanted to make it accessible to people. You have to cross the stream in order to access the station, and actually this bridge was taken out by a recent storm. So again, it's something to consider about access and how easy that access is. This station is hard to access now because this footbridge is no longer usable. So, all right. So once you've considered those dynamics to station positioning, then you can go and take your station and your supplies and install. So some of your main installation supplies. It's pretty straightforward at this point. You've got couplers to link to a small pole and a long pole, and you've got a cap to top the long pole. You've got tent stakes to tack in the wires along the stream bottom, and then you've got zip ties to secure the wires all along the station. So you're going to use one small pole and one large pole. The small pole is going to go in first into the ground, and then the large pole is going to attach to this small pole via these couplers. You're going to build your sensor bundle out there. You're going to need to cut this PVC to length according to stream depth. You're also going to drill a hole in the PVC. That's something you can do out in the field or in the office. You're going to use these drill bits to drill that hole. That will fit over this rebar, and you'll use this pin to attach the PVC to this pole in the stream. And then you're going to take all these other supplies out with you, gloves, clips for the zip ties, wrench, hammer, your zip ties, so on. Your wrenches for tightening your poles up, so on. So I'm going to breeze through these installation steps. First, you're going to use two of these rebars. One is to clear a hole. So you're kind of going to clear a hole in the stream bottom after you've chosen your position for your sensors. You're going to use one rebar to clear a hole, and then you're going to use the second one at the end to put in there and mount your sensors on. You're using two because as you pound on this first one to clear a hole, it causes this top to splay out. And if that splays out too much, you're not going to be able to fit your rebar over. So you have one kind of throwaway rebar that you use to clear your initial hole. On land, you're going to put this small pole into the ground. You're going to attach a coupler. You're going to tighten that coupler here to that low pole. And you can use a wood block to get that in a little further after you're attaching the coupler so that you don't damage the coupler. These wood blocks can be very handy when you're hammering on these different items so that you don't cause damage to the thing you're hammering on. Using two wrenches is also a key technique in this installation process in this step and others. And then you're going to attach your long pole, excuse me, to the short pole. You're just going to get that all tightened up, and you're going to make sure the whole setup doesn't spin. It's an iterative process, and sometimes you have to do it over just depending on what your soil is like. Oftentimes you'll hit boulders and gravel and stuff underneath, and you may need to reposition. So this is all kind of an iterative process according to site-specific conditions. So again, using two of these wrenches to tighten things up, making sure it doesn't spin. And then one thing you can also do for greater integrity, especially in streams that will be out over the banks and having significant flows, is you can take a bigger PVC and kind of slide it down on top of this setup here. And the idea with that is that it protects that coupler. That coupler, although it makes it easier to put the station in so you don't have a giant pole that you have to reach to hammer this part in, that coupler is a weaker spot. So you use this PVC to protect that weaker area. So then you're just taking your hose clamps, kind of fitting them in here on this bar, and that will be so that you then can mount on the logger. Encouraging people to mute. Again, I'm getting some feedback. Then you're taking this nut driver tool and tightening this logger box onto your pole that you just mounted in the stream, tightening these down and securing it. You're going to get ready with you're going to have your wires kind of slung up here, and you'll tend to those a little later as well. Now you're going to go back into the stream and you're going to cut your PVC. So you're going to size up your PVC. You're going to have your rebar driven into the stream bottom, and you're going to get the proper length. So she's measuring here the proper length of the PVC, and she's going to use these cutters to cut the PVC and slide it down on top of that rebar just right so that it's flush with the rebar. and so that those holes are directly lined up. Then, then you're going to finalize your sensor bundle. You're going to attach your loose sensors to the bundle, excuse me, to the PVC with your larger hose clamp, tightening it with this nut driver. And then you have your final product, and it's ready to go in over top of the rebar and be put in place with this rebar pin. So then that's all she's doing here, is putting the bundle in on top. And then there is a process of, then you're going to go at it with the zip ties. Here on the sensor bundle, kind of securing the wire so that it's not dangling in the stream and having the potential to snag things. And then you're going to fit this pin in there. When we do this type of work, when you're removing this pin, it can be very useful to take a picture before you take the pin out, so that you know exactly how the sensors are positioned. You want the sensors positioned in a certain way. You want the turbidity sensor facing out into the stream. And generally you want the CTD positioned so that the screw heads are facing out so you can actually clean them. I think I may have missed that here. Well, one of these slides. Anyway, certainly you want the CTD positioned so that you can clean those screw heads. And when you're pulling the sensor bundle out, when you're putting it back on, you just want to make sure that you're doing it in a consistent way and that you're putting the bundle back so that the PVC is flush with this rebar. As you can imagine, with depth, the main reason for having this pin so that you can get the sensors back at the same position is for depth. Conductivity, temperature are going to read exactly the same regardless of the position that it's at, but depth, you really need to be consistent with how you position the sensors. So then you're just going to take these, you've kind of got everything set up at this point. You've got the sensors in the stream, you've got the logger box installed. You're going to attach these wires to the stream bank with these tent stakes. You can use zip ties to attach to loose, to accessible roots, and just securing that wire all the way up the stream bank so that it is not going to be flapping free when water comes up and snagging debris or hooking onto a big log coming by or anything like that. But you want to leave a little bit of slack, in the wire so that you can sort of adjust things. So when you actually take the bundle out, then you can actually have a little bit of wire to work with. So as I mentioned earlier, there's a lot of subtlety to this. And it's kind of an iterative process, especially when you're doing it for, as a kind of a new thing. So then you're going to just simply use your already assembled solar panel and bracket with your U-bolt and attaching these to your logger pole, considering direction of sun, considering foliage. This can be adjusted season to season, but certainly considering where the most sun is going to be so that you can get proper charging. Then you're going to do some last minute items like attaching the solar wire properly to the Mayfly board. So this is coming out the bottom here, attaching the solar wire to the component of the wire that goes into the actual Mayfly. And then you have this part here, which is getting some feedback. Please mute if you're unmuted. This allows pressure compensation. So you don't want to fold this or crimp it in any way, or it'll affect the readings. So that's an important thing to consider when you're tying up and getting these wires situated, getting them neatly kind of aligned here with zip ties. And then you're just kind of trimming up all your zip ties. And then you've got your installed station. So you can see here in our examples, we have these sensors down here. Water's flowing this way. You can see these are kind of protected by this bank in this tree. Wires leading up here, tacked in with tent stakes all the way up to the logger here. Solar panel positioned pointing out this way to get some good sun hit. This one's out in the open, so there's no real worry about solar coverage. You can see here, again, it's kind of just, you know, almost always these things are going to be close to the bank. And, you know, sometimes you're not going to have a perfect situation. You just deal with it as best you can with regard to the specific spot that you're trying to monitor, which is obviously the most important part, that you're getting it in the right position for your actual monitoring questions. So again, you can see here using some extra roots here to attach to and tacking it in with tent stakes up here to the logger. So that sort of wraps up the programming building installation process. So how can you build these stations? What are your options for building these stations? I think one of the best options for folks that are not, for people that may be doing this for the first time and that may need, may not be electrical engineers or someone who has long-term experience in working in this realm of things, is to attend an EnviroDIY build workshop. These events are listed on EnviroDIY site. Our next workshop is tentatively planned for early 2022. So feel free to be in touch with me if you'd like to be added to that early access list. We haven't set a date, but presumably it will be sometime in the first several months of 2022. You can also use the manual. The manual certainly takes you through in a stepwise fashion how to build these stations. There are also a nice list of video tutorials at this point. One of those being a full build workshop from May of 2020. So we recorded that entire workshop, and Cheryl, actually, I think that was one of the main ways that Cheryl built her stations, was following through this workshop. There's also installing videos and maintenance videos. So that's a good resource. And then you can certainly use the forum, the EnviroDIY.org forum. Shannon Hicks and Sarah Damiano are actively providing feedback on that forum, as well as feedback from the 700 or more people on the EnviroDIY.org list. There's quite a few people that are very active, and so it has become a good support community for those that are working in this DIY realm. And that pretty much concludes it. I wanted to mention a few updates to EnviroDIY and the Mayfly that I alluded to earlier. There is an EnviroDIY shop, and Shannon just posted all of these new products there. This is the new Mayfly Data Logger. There's a new cell board that is going to be used. There's this really nice display panel that you can put on the Mayfly, and I'll show that in a second. But this Mayfly board is a upgraded version, and it is essentially going to allow us to communicate with some, for instance, the new turbidity sensors all required this new Mayfly so that they could work at in the 12 volt range, which the previous Mayfly was not able to do. So this will allow us to work with these new turbidity sensors. This new Mayfly board, excuse me, this new cell board is also hopefully going to be, we've had a few issues with previous cell boards. First, we were 2G, that got phased out, just progress. And then we went to 4G. There were some issues with the manufacturer boards that we were getting. So Shannon designed this new board, and we are just starting to use this, and it seems to be functioning much better. And that is going to be for sale soon. And then this display, which is super nice because you can put it on the Mayfly and you get instant readouts of your data. And this is also potentially going to offer options for low-level programming options for the Mayflies. So I think that does it for me, and we can go on to Cheryl. Cheryl wrote one